Hello everyone, I'm Sai Venkatakrishnan, a PhD scholar from the Department of Computer Science and Engineering. So welcome to Introduction to Haskell Week 3 live session. The agenda of the live session would be, we'll be discussing the practice questions released as part of the week 3, and if you have any queries regarding weekly video lectures or the previous week's video lectures, you can unmute yourself and ask the questions or post it in the chat box. So this would be this would be a sort of like a doubt solving session mostly, right? So let's get started then. So I have so we have around like four practice questions, four questions which were present under the weekly live session under the practice questions section. So let's look into those first. So what's the value of the following expression? And they have asked us to find the value of this expression. Drop 20, filter, the filter condition is greater than 50, and you have this list. So has anyone worked out this question?
Yes, sir. I worked out.
Right. So will you be able to share the answer, the final answer?
Final answer will be actually here we are taking a multiple of 3 and then we are finding whatever the greater than of 50. Okay, so it will be like 51, 54, 57, 60
Right. Right.
up to it will go 90.
Okay. So the final answer that you get.
It will be null because we are dropping 20. So there are, I think, 1, 2, 3, 4, 5,
Okay.
6, 7, 8, 9, 10,
Right.
11, 12, 13,
So
14. Total 14 is there, so it will be empty
okay.
string.
Right. Null is the correct answer. That's good, Mukesh. So we'll just look at how we get the answer, right? So we have the initial list which is provided to us, which is this thing, 0, comma 3 up till 90. So the sort of this initializing the list based on this arithmetic progression, and the difference between two consecutive elements is 3. So based on this only we have to get the list series. So we have 0, 3, 6, that is all multiples of 3 up till 90. So these are all the this is the list, and we have all multiples of 3 between 0 to 90. That's what this corresponds to. Now coming back to the other parts, so this is the first part which we have solved, and now we have this filter function. So the filter function is nothing but it takes two parameters. The first parameter is a condition, the second is a list. And the filter function, what it does is it retains the list elements whose list elements only if whatever function it has passed, right, this condition f. So f of x is true, where x is the list element. So only if applying this condition, whatever is passed to the filter function on every list element, only if that condition passes, satisfies, then we retain that element in the list, otherwise we drop all the other elements. So that's what the filter function does, and here the condition is greater than 50. So basically all the elements which are greater than 50 are alone retained in the list, and the elements which are less than 50 are dropped from the list. So the output of this particular filter uh, function would be as follows. So as Mukesh had mentioned, greater than 50, what's the least multiple of 3? That's 51, and up till 90 it will go. So 51, 54 up till 90. So this is the output of the filter function after applying the constraint greater than 50 on this list. So we have obtained the list till this operation, up till the filter operation, and now we have to apply this particular operation, which is drop 20. So drop 20 is nothing but, so drop takes two parameters, it takes n and it takes the list. So n corresponds to number of elements to be dropped, from the list, starting from the first element at index 0. So just to be sure, right, because the indexing starts from 0. So starting from the first element, that's the 0 index, it drops, say, those many number of n number of elements from this given list. So we have drop 20, which is applied to this list. So what it means is the first 20 elements in this list is removed and the remaining list is returned as the final result. So as Mukesh had mentioned, um, from 51 to 90, right, if you count the number of elements, so 51 is 3 into 17, if I'm correct, 3 into 17, and 90 is 3 into 30. So in between there are around like 13 to 14 multiples of 3, right, 14 multiples of 3, so like 14 elements in the list. And if you are dropping the first 20 elements, it means that you are returning an empty list because there are just 14 elements in the list. So on applying this drop 20 operation on the list, you get an empty list whose type is of integers, right? So the answer for the first question is you get an empty list. So any doubts in the first question? Okay, that's good. Then let's move on to the second question. Right. So what's the type of the following function? Anyone wants to try this question?
Okay, how I solved it, let me tell you, because for x and z, we are putting that double plus, okay? And we know that double plus is taking as a list in both the sides. So x and y will be a list of some type, okay? And y is written before the colon, that means y should be a some int value or some boolean value, means some value will be there, single value. So I think answer will be this third number.
Okay. So
Yeah.
some are telling option A, some are telling option C. So let's look at that. So the given function is f of x y z is equal to y colon x plus plus z. Right. So the correct way to approach this question is, as Mukesh had mentioned, in Haskell everything is strongly typed. So and also you it, the cool thing with Haskell is it does not say in this example, right, you are not sure whether x is particular sort of like an integer or a character, or those things you are not sure of. You just have to see what um, uh, you just have to see what operations are performed on each individual element or each argument passed to the function. So here there are two operations that are being performed. One is the cons operator, the construct operator, which adds an element to the head of the list. So this is the first operator. The first operator which is being used, the first two operations are being used. One is this cons, and the second is this plus plus, right? So these are the two operations that are being performed on the arguments which are passed to the function. Okay, these are the two operations. Now first see this operation. Let's first see this operation 1, which is the cons operator. So what does the cons operator do? It takes, so if you look at the type of the cons operator in GHCI, it will return back a type where it takes one element of type A, it takes a list of type A, and it will return back a list. So this is the type signature of this operator, the cons operator. So basically it gets an element, gets a list, and adds it and returns back a list, right? And if you know the semantic meaning, that's the actual what the cons operator does. It adds the element whatever is passed to the head of the list. So this is what it does. So now if you notice, you have the parenthesis which is mentioned over here, right? So basically cons, if you take the cons operator, you will have you see like y is the first element which corresponds to this type A. Okay, so y corresponds to A, right? And this whole thing, which whatever is present within the brackets, corresponds to this type. So the whole thing x plus plus z corresponds to type of list. Okay, so this is what we have inferred till now after looking at the first operation. So now let's look at the second operation, which is plus plus. So plus plus is between the concatenation operator. It is applied between two arguments, which is x and z. So x plus plus z, right? Now if you look at the plus plus type, right, in GHCI, in the Haskell interpreter, you will notice that it has the following type. It takes two lists and returns back a list. So here it takes two lists and returns back a list. So, and the semantic meaning, what plus plus actually does is it concatenates the two lists. Concatenates the lists together. So this is what plus plus does, concatenates the list together and returns back the concatenated list. So for example, if it's 2 comma 3 plus plus 3 comma 5, so it will return back 2 3 3 5, concatenating all the elements of the list. So this is what plus plus returns back. So here x and z corresponds to the first two arguments, the two arguments which are being passed to the concatenation operator. And what are the types? It has a list of elements which is having type A, and another list of the same type A. So x corresponds to type A and z corresponds to type A. Now we should also check that the result whatever is returned back after this cons operator is type A. That's a result, and this should match with the cons operator second argument. So if you notice, the second argument of cons A is also a list of some type A, right? So here this matches. So whatever is the type of the concatenation function, whatever is returned back, is a list of some type, and this matches with the type of the second argument which is expected in the cons operator, which is type A. So this matches and everything type checks. So finally what we get is we have x, y and z. So x is of some type, list type, and y is of y is just an element, not a list, and z is of some element uh, type which is same as x, right? And y is also of type A. And finally, what should be the result of the function, whatever the return, the returning value, what's the type of the result which is being returned by the function? That should also be type A, because the result of this cons operator which is applied last, right? This is type A, which is a list of elements of type A. So this is the result type. So finally, the function type if this will be as follows: a, a, and a, and this corresponds to option C. Okay, so option C is correct. The other options are wrong. Okay. And you might wonder why all the types are of like A, and not like, why not it can be say like A, B, A. So the reason is actually because if you notice that you see like operation wise, right? You infer the type. So the type. So initially, what you can do is, when you first look at the cons operator, okay, so okay, first let's look at the plus plus sign with the concatenation operator. So it tells that all the two arguments, the two arguments which are passed to the concatenation operator should be of the same type. So here, instead of a and a, right, I can write it as b and b also, right? And B and B and B. So X and Z should definitely be of the same list type. That I am sure, because the concatenation operator will work on lists of the same type only. So that I am sure. Now coming to Y, right? Coming to the cons operator to find out the type of Y. For this, the cons operator, uh, the type of the cons operator is, it takes an element, say some type C, and it takes a list of type C and returns back a list of type C. That's the cons operator. Now, so this is the type of Y, and whatever is passed as a second argument, which is the whole thing, uh, this result, right? This is the type of the second argument, and this is what is returned back from the function f. This is the result, and this is x plus plus z. This is the second argument. Now you have you know that x and z and whatever is returned back after this concatenation is of type B. All the elements are of type B, and you know C is the type of the element Y, and the second argument should be also be of the same type. Now, based on this, right, you sort of get an equality. That is, you infer that I am just uh, naming these two the type placeholders differently, but when we combine both these operations, the cons and the concatenation operation, and the way they have been combined, we find out that the type of B is the same as the type C actually. The type B and type C are the same. So that's why we arrive at this final answer where all the elements are of the same type individually. Some are the lists of the same type, some are just like a individual element of that type. So that's how we arrive at this specific type signature. So you can you can start out with different this parametric name B, C, and all those things. But finally, you should ensure that it's type checks. So for type checking, it should be of the same type, right? So then B or C, it will all be the same, and you can just replace it with a common type holder, which is A. So any doubts in this question? Mostly 1 comma 2 plus 3.5. Yeah, that will work because we are not assigning a specific type to 1 comma 2. That's a good question, Tyagarajan. So we are not assigning a specific type to 1 comma 2. So it will work because it will because the plus plus operator, when it before it executes, it will look at both the types of both the arguments. So here 1 comma 2, and here it's 3.4 4.5, right? So here you might assume it to be, say, integer list, and here it is float. But all integer lists are like subset of float, right? And since you have not explicitly specified that you want to treat this as an integer list, Haskell would be Haskell would assume that in order to type check safely, it will assume this to be a list of floating elements, and it will type check. It will, I guess, it will change it to 1.0, 2.0. Whereas if you explicitly name a variable, say like y equal to 1 comma 2, and then y as list of integers. So if you explicitly mention like this, and then if you execute this plus plus operation, it will fail, because at that time Haskell cannot change the type, because the programmer view have specified this is what 1 comma 2 should be treated like. It should not be treated like a float. So in that case, Haskell will give out a type error. Okay, right? So okay. So in that case, let's move on to the third question. So before that, all these A and B and C, I guess you all understood. These are just placeholders, and it can be anything actually. It can be any arbitrary alphabet actually. So in Haskell, it's usually like small, lowercase, starts from A, B, and C. Okay. So in that case, let's move on to the let's finish the fourth question, and then let's come back to the third question. Okay. So we have the following oops. So we have the following expression: take 5 filter of less than 30, 0, 8 up till 100. So anyone wants to try the answer? What would be the answer for this expression?
Yes, 08 16 24.
Right, 0, 8, 16, 24. Okay, so we have two answers. Okay, so some are telling 0, 8, 16, 24. Some are telling 0, 1, 2, 3, 4. Okay, so let's look at the expression. So this question is somewhat similar to the first question which we had um, looked into. Okay, so first we'll find out what this list is. So first we have this list 0, 8 up till 100. Okay, so there's nothing but all multiples of 8. This sort of like an arithmetic progression through which you initialize your. So this is 0, 8, 15. 16 up till 96. Yeah, up till 96. Right, all multiples of it. So this is what your list L is. Now you have your filter function, and as we have seen, it takes two arguments. One is a function which is less than 30. Only if this condition is true on every list element, those elements alone will be retained. So this is your list L. So on applying this filter function, you get all the elements which are less than 30. So we have 0, 8, 16, 24 and 32. No, it's not less than 30, so we stop. So this is the final result that you get on applying this function, the filter function, on the list 0, 8, 16 up till 96. And now you have this take function, take 5. So take function takes two arguments, one is n here which is 5 and the other is a list. So take takes just the starting 5 elements of the list and returns it back as the result. So here on applying the take function, the take function to this list, you pretty much get the same, because there are just 4 elements and you want to take the first 5 elements, so it's pretty much the same list. So this is the final answer, 0, 8, 16, 24. So any doubts in this question? I guess it's pretty easy. Okay, cool. So in that case, let's move on to the final practice question. So what's the value of the following expression? Length of fold R, they have given function f, and then initializer value is 0. So we have this whole big expression over here. So anyone has tried this question?
I tried, but it is not working.
Right, okay. So did you get stuck at some place, or did you arrive at any final answer, that numeric value?
Actually, what I done, I am able to crack this fxy and this modulus value. Okay, but my doubt is that here, if you see the x is int value, okay, there is only a doubt. But when we are putting in a folder, and after that, why we are putting as a list, that only I am not getting.
Which one? This
So
one, right?
so I just I just try this fxy and I am able to break it this one. That means if my x is a modulo of, means it's a even number, then what we are doing, what we are taking that x value, and then whatever the x values are coming, we are taking the head. For example, it is from 0 to 10, so it will take a 0, and x, suppose x is 0, to 0 plus 0, and then y will be 0 to 1, so it will be 0 0 0 to 10. And if it is odd number, then it will be, if x is 0, then 0, then 0 to 10. But after adding this filter, I am getting confused. It's not working for me.
Filter. Where is the filter function?
No, no, filter not this folder are.
Folder. Okay. Right. Okay. Then let's look at this folder. So understanding this folder is, I guess, pretty important, because this can be asked in your examination, because it's sort of a tricky, and like it's practically it's a very powerful function, folder, and it is like highly used in these functional programming styles, right? This fold R and fold L, all these stuff. So so what we can do is we'll look at the trace of evaluation, how it goes, right? So here, so first, before starting this, let's understand what fold R does. So folder takes, what's the type of folder? What does folder do? It takes a function, right? So before that, let me just check the type signature. Am I audible?
Yes, sir.
Right. So let me just check the type of folder. Yeah, thanks,
A,
Asaf.
B, B.
Yeah, I got it. So for now, I'm just removing that foldable T from the equation, from the type signature. It's sort of advanced, so I didn't want to confuse you. We'll look at what that foldable T means in the next upcoming sessions when we discuss more about types. So for now, let's look at what folder does. So this is the type signature of folder. So it takes three arguments. Okay. So the first argument, as we know, it's a function. A function. The second argument. So here, just let's assume it's a list. Okay. So it takes an element B, element of type B, some element, and here also it takes. Okay. So here also it takes an element A. So here, if folder if right. So here, just instead of this TA, whatever was given in the type signature when you what you get from the interpreter, let's just replace that with list of A. Okay, for the time being. At least in this week session, we'll assume it to be this type. So this is the type signature. So it takes a function whose type signature is this A, B, B. It takes two arguments of type A and type B and returns uh, result of type B. And the folder function takes this function as the first argument, an element of type B as the second argument, and the third argument is of a list of elements of type A. So this is what folder function does, the type signature. And what it semantically does, what's the meaning of folder is, it sort of applies this function. So let's assume this function as f, right? It applies this function f on between start. It applies this function f on each element of the list. So on each element of the list. So this is sort of like a binary function. Binary function as in it takes two arguments. The first argument will be each element of the list iteratively, and the second argument is the this sort of like um, the initializing element. I forgot the actual name for what we call this element. So let's assume this to be the initializing element, right? Something like this. So this element would be taken as the second argument. Let's assume this as y. So basically, what folder does is on every iteration, the actual implementation of folder would be as follows. If it's the if it's an empty list, it's just the empty list. Otherwise, if it's folder, say it's getting an f and then it's getting an element y, and then it's getting a list L, right? So if the list is not empty, and what it does is it calls this function f on x and then y, and what this y is actually, it doesn't pass y immediately. Instead, the second argument is this folder of f, y and x's. So this is the second argument. So basically what folder does is, if you have the list 1, 2, 3, 4, 5, and what it does is, when you pass say a function f and say some element 0 as y, so y is 0, this is the list and this is your function f, means say this function f is an addition operation or something like that, something it does. Okay, so what it will do is, I will call folder of f y this list 1, 2, 3, 4, 5. Okay, and it sees that this list is non-empty, so the second condition, right? So the second condition is, so actually over here, if it's an empty list, it returns back y actually. Okay, so this is the base condition actually. It doesn't it just returns back y. This is the base condition. Okay, so um, so you have a folder fy12345. So now what it does is, it calls f, it applies it on the first element, it starts from the head of the list, so f of 1, and the second argument, it doesn't, it's not y, instead it calls folder again. Now folder of f and y whatever is being passed, say it is 0, right? So y is being passed as same, and now the tail of list 2, 3, 4, 5. And now again another step, since you have invoked folder again, f of 1, now f of 2, which is the head of the list over here, f of 2, and now the second argument is folder of f, y and 3, 4, 5, the remaining list. And now since you are calling folder again, it is f of 1, f of 2, now f of the head element f of 3. Now the second argument to this f is folder f, y 4, 5, and you are calling folder again, so this is f of 1, f of 2, f of 3 and f of 4. So all this expansion I am doing based on this. So if I get a non-empty list, the first argument is x and the second argument is applying the result of folder f, y and the remaining list. That's the second argument. So that second argument only I am finding out by these recursive calls to folder again and again. So the top element is 4 over here, that's the first argument, and the second argument is folder f, y and 5. So you will just close the exact same number of parentheses. So you have f1, f2, f3, f4, and then folder of fy5 is f5, and the second argument is folder of f, y, and finally you have this empty list. So you are just assume I'm closing all the parentheses properly. So now this folder fy empty list, it returns back y actually, right? So if it's just a empty list, what's the answer is, it just returns back y, which is 0. So f of 2, f of 3, f of 4, f of 5, y, and okay. So now I have stopped all my calls to folder. My folder has now in the returning stage, it's returning back all the second arguments whatever it's computing. So using that only, so you have all these pending f's over here. So what has happened till now is, once you start calling folder, right, it will call this f function on every element of the list, applying this argument y, so this applying f as the first, and the first argument is x, that is the list element. But the second argument is starting from y, it will iteratively sort of like recursively apply the result of the folder to f as a second argument again and again. Okay, and once all the calls to folder has been done, now it's the time for the evaluation of f. And the evaluation, if you notice, the even though it was first applied to the head of the list 1, right, you didn't have the second argument to this f at the starting itself. You need to evaluate this whole expression in order to evaluate this f. So this sort of this dependency, and for this dependency you have to evaluate this whole expression f2, f3, f4, f5, all these things, and then only you can evaluate f1, which is the one which you got first. Okay, so basically what it means is, if we just start evaluating, so assume f to be a summation operation. So in that case, f5 of y is just 5. Now 4 plus 5, this will be 9. And now 3 plus 9 would be 12, which will be the second argument to this f. And 12 plus 2 is 14. And finally you get f of 1 comma 14, which is 15. So let me just give you a 30 seconds break, right? As in, you just stare at this whole thing, f of 1, f of 2, f of 3, how we arrived at this. I'll be back in a second. Yeah, sorry for the delay. Okay, so we looked at a dummy folder function, and why is it named folder? We'll look at it now. So when we start evaluating this, right, what this implementation does is, you have this list 1. Am I audible?
Yes, sir.
Yeah. So you have this element list 1, 2, 3, 4, 5. Okay. And what it does is, it initially starts from, it initially has, you have this, function f, and this f is applied to this element 1, and the second argument is the result of 2. Wait, there should be some other good way of drawing this. It should come like, right side. So this is what it looks like actually, right? So you start off from the head of the list, which is 1, and f is applied to 1, and the second argument you don't know at the start. So what you do, you again start, you go down one element in the list, right? So basically what folder means is right to left, from the rightmost element to left, from right to left. So the order of evaluation is from right to left. So the function f and whatever is the initializing element y which is given, right, it is applied first to the right element, and that result is the second argument, and the first argument would be the next element of the list. So that's the order of evaluation, right to left. So that's why you see over here, after we call all the folder in recursion, right, one after the other, finally after all the folder has been done, you notice at this step, right? So this evaluation, so till now you have been calling f only, f is being invoked, but it has not been evaluated. Okay, the evaluation starts only from here, from the innermost f5 of y. So this 5 is the rightmost element. So here the evaluation starts with the first argument as 5 and the second argument as the y which was being passed throughout all these recursive calls. Okay, so I got this term. So the term is known as an accumulator. So basically why it's called as an accumulator is, this y accumulates throughout all your recursive call. It accumulates, and finally when it reaches the last element of the list, it is applied to that list element along with that function as an argument, and the evaluation starts up. Okay, so here when you apply f5 and y, right, the result of this is returned back, and it is applied as the second argument to the f function which takes the first argument as 4. So that's what this diagram over here represents, right? So your evaluation, so maybe I should draw it in the opposite way to make sense. So the evaluation first starts at 5. So we have 0, f f05, okay, and this result is then provided to f4, and this is then provided to f3, and this is in provided to f2, and this is it provided to f1. So this is how your evaluation goes. So all the recursive calls that you made, finally when it reaches the last element of the list, that's where your evaluation starts actually. Till then it's just your calls being made, the recursive calls. And finally when it reaches the last element, it reaches the base condition where just the actual second argument y, the accumulator element which was being passed, returns back, and your evaluation kicks in. And then all these sequences of ifs that had been called, right, this gets evaluated from right to left, starting from the innermost, the rightmost to the leftmost. It gets evaluated, and then finally the result returns back. So that's why it is known as a fold R function, and this R denotes that the evaluation starts from right to left. In a fold L function, it's basically the opposite. You will be doing the evaluation from left to right. So finally, after all the so you won't the recursive calls will be made, but the evaluation will be done from left to right. Okay. So this is what foldr does. And now in the given example over here, length of foldr f of 0 is to 10. Okay. So let us okay, so let me just rewrite this expression. So any doubt in what the foldr does actually? So basically what it does, it folds your list. If you have a list of n elements, you apply some function on each element of the list, initially with this accumulator y as the second argument, and then that result is promoted throughout the list elements as the argument to this function f, and your whole list is folded into one element which is of type b, which is of type of this um, accumulator y, because whatever you are passing right as the accumulator, you apply that to each element of the list, and finally you fold the list into just one element. You fold it literally, and that is the result. And how this folding takes place is, in a folder you start folding it from right to left, and in fold L you start folding it from left to right, the folding as in the evaluation. So any doubts in this folder function till now?
No, sir. Clear, clear.
Okay, cool. So let's look at the question then. We have a length of folder f of 0 is to 10. Okay. So we have the following is the question. Length of folder f 0 is to 10, where f x y equal to, if x mod 2 equal to 0, x plus, okay, then else x y x plus head y, and then y, and then we have if x mod 2 equal to 0, right. So this is the function. We have to find out what the length of the list of this expression, whatever folder returns back. So here, since I'm using the length operation, length is supposed to be used on list. So the result of this folder is a list actually. So basically folder, when you are folding the function, you assume it to be an individual element but it can be a list also, can be returned. That might be the type of the accumulator. So that's why we have mentioned over here it can be of any type. If you notice the type of the accumulator, whatever this function, this y right over here, this accumulator, it can be of any type b. So it can be of type list also, or it can be of any type. So this b over here is now is of type integers. It can be of any type, right? So we have this over here. Now let's do. So one thing to note is, what does this mod 2 denote? This mod. So mod is this function, sort of it gives out a reminder. Mod is actually a function, okay? But here, so usually a function, if you remember, it would be applied like f of xy, where this is the prefix notation. But here mod is a function, but it's being applied in the middle, similar to a infix operator, similar to say x slash 2 or x plus 2. So how a function name, that function is being applied as an infix operator is, you just have to add the backtick, this backtick at the start and end of the function name. So if you just add backtick mod backtick, this becomes an infix operator. So basically, say if you have a function named foo, so instead of having foo xy, if I add backtick, it can be x backtick foo backtick and y. So this sort of an infix operator, and this would be same as this x plus 2, or however it works, it will be the same. So by adding this backtick, it becomes it can be used as an infix operator in the within the expression. So this is something I just wanted to mention. So now let's look at what this does. So let's expand what foldr does. So foldr, the base case would be it returns back the element y itself. So the element, the accumulator element. So let's be clear over here. The accumulator, which is a list with element with type 0. Sorry, a list with the number 0. Okay, and if the list is non-empty, then it's sort of this the expression f of x. The second argument is foldr of f, uh, whatever the accumulator is, followed by the tail of the list. Okay, so it just invokes f on the head of the list, but the actual evaluation, it will start from the rightmost. So till then it will just keep on doing foldr again and again, and finally when it reaches the rightmost element, then the final if this accumulator would be returned back as the second argument, and the evaluation kicks in. Okay, this is the logic. So now just expand what the evaluation would look like. So initially it will be a foldr of f 0 0 to 10. Okay, so the 0 to 10 is 0 1 2 3 4 5 6 7 8 9 10, totally 11 elements, right? So now if I expand this folder, it would look like folder, sorry, it will be f of x. X is the head of the list. Okay, so this is the list, and this is x, and this is the remaining. Okay, so f of 0, and what's the second argument? Folder time, in again invoking folder. Folder f, what's the accumulator? The accumulator is 0, and the remaining list is 1 up till 10. So now calling again this folder. Okay, so this is f of 0, now f. So everything I'm looking at this condition actually. this condition is the key condition. So now invoking folder again, f of what's the head of the list 1. So f of 1, the second argument I don't know. Again for that I should invoke folder, because my folder, the evaluation should start from the rightmost element. There only the second argument is the accumulator element, which is this. So all for all the remaining evaluations, that is the for all the remaining elements in the list, the second argument is the result of the previous evaluation. So the initial one is only the rightmost element. So for that only I should be using this accumulator element as it is. So till then I should be calling folder again and again to find out the second argument. So again it is folder f0, and now we have removed this set, so it is 2 up till 10. Okay, so f of 0, f of 1, folder f of so if this folder, if we just do, so it will be f of 2, and the second element would be folder of f of 0, and then 3 is to 10. Okay. So if I just repeat the same thing for up till say 8, right, the list element 8, so what would it look like is f of 1, f of 2, f of 3, f of 4, f of 5, f of 6, f of 7, f of 8, and here it will be folder f 0, and then 9, 10, and finally it will be f of 0, f of 1, f of 2, f of 3, f of 4, f of 5, f of 6, f of 7, f of 8, f of 9, and then the second element for this would be folder f 10, and finally you get the empty list. And on getting empty list, what it does is it applies this. So f of 0, f of 1, f of 2, f3, f4, f5, f of 6, f of 7, f of 8, f of 9, and finally this folder of f of 10 is nothing but f of, so folder of uh, uh, f of 10 and folder of f uh, okay, so this should be actually a small mistake, so this should be 0 and this should be 10, right? So f of 10 folder of f 0, and then it's the empty list. So now we have reached this base condition over here, folder on an empty list, and the accumulator is 0. So now it returns back this accumulator element. Okay, so let me use a different color pen. So it will be f of 0, f of 1, f of 2, f of 3, f of 4, f of 5, f of 6, f of 7, f of 8, f of 9, f of 10, and this is the accumulator element. So now it is up to, now we should start evaluating. We have reached the rightmost element in the list. So any doubts till now, till the part we have reached the starting stage of evaluation? Okay, So in that case, let's start evaluating. So the function that we have is if x mod 2 is equal to 0. So that is, if the first argument is divisible by 2, we should construct a list as following: x plus zy, um, and then y, or else we should construct this. So let's just note it down here. If it's even, if it's odd, then x plus head y, and then y, or else x1. So here, if you notice, the first argument is of type integer, which is an x individual element, and the second is actually a list. Why? Because that's what your accumulated element is, and also if you notice, you are using head of y, so it means y is a list. And also the cons operator, the right hand side of a cons operator should be always a list. So that's why we have this y over here. So let me just write it more clearly: x plus head y, and this is x. Okay, so this is the function f. So now let's start evaluating. We have f of 0, f of 1, f of 2, f of 3, f of 4, f of 5, f of 6, f of 7, f of 8, f of 9. So evaluating f10 of 0. So 10 mod 2 is 10 is divisible by 2. 10 is an even number. So x is 10 over here. So this is x, this is y. So we get what do we get? Yeah, we get a list where my first element. So this is triggered. This condition is triggered. So 10 comma x plus head of y. So that is 10 plus head of y is 0. So 10 and then y, which is 0. So this is what you get. Okay, and this is all like closing parenthesis. So we have evaluated f10. So we have done the rightmost evaluation. Now the result of that should be applied with the second last element of the list. Both are applied as arguments to the function f again. So the evaluation goes from right to left. Okay, so now again f0, f1, f2, f3, f4, f5, f6, f7, f8, and now it is f9 of this, right? So let me so f8 of what's the second argument? 9 is a odd number, so this condition is taken. So x is 9, so 9 comma 10 comma 10 comma 0. So basically um, it adds the list element to the top of the list y. So that's what we get over here. Okay, so in the same way, if we just keep on going, we will have so let me just for okay, let me just write it down. F3, F4, F5, F6, right? And now F7. So on applying f of 8 along with this function, we get the following, which is 8 is an even number. So we get 8 comma 8 plus head of y, which is 17, right? And then the remaining elements of y, which is 9, 10, 10 comma 0. Now we have to apply this function. So f of 0, sorry, f of 0, f of 1, f of 2, f of 3, f of 4, f of 5, then f of 6. So the result of this f of 7, whatever is, since it's an odd number, you will have the second condition, which is just adding 7 to top of the list. 7, 8, 17, 9, 10, 10, 0. And now applying this function. So f of 0, f of 1, f of 2, f of 3, f of 4, f of 5, right? And next in line is f of 5 and this result. So applying 6 to 6 and this list to f, the even condition, which is nothing but adding x to the top of the list and then x plus head of y, which is 13, and then the actual 7, 8, 17, 9, 10, 10, 0. And now just 5 more evaluations, f0, f1, f2, f3. And now we should evaluate f4. The second argument would be this evaluation, which is just, since it's an odd number 5, 5 just gets added to the top of the list. So it's 5, 6, 13, 7, 8, 17, 9, 10, 10, 0. Okay, so now f of 0, f of 1, f of 2. Now the next evaluation is f of 3 should be done, and this result. So 4 is an even number, so the first element should be 4, which is x, then x plus z of y. So 4 plus 5, 9, and then the remaining list 4, 4, 9. The remaining list is 5. The whole list as it is, right? So 5, 5, 6, 13, 7, 8, 17, 9, 10, 10, 0. Okay, and now we have f of 0, f of 1, we have f of 2, and what's the result of this previous, what's the second argument? The result of the previous evaluation. So 3 is an odd number, so we just add 3 to the start of the list. 3, 4, 9, 5, 6, 13, 7, 8, 17, 9, 10, 10, 0. Okay, and now you have f of 0, then f of 1, and the second argument is you apply 2 and this list. So 2 is an even number, so 2 and then 2 plus head of list 5, and then 3, 4, 9, 5, 6, 13, 7, 8, 17, 9, 10, 10, 0. And finally you have to apply f of 0, and what's the second argument? The evaluation of this, which is, since 1 is an odd number, you just add 1 to the head of the list. So 1, 2, 5, 3, 4, 9, 5, 6, 13, 7, 8, 17, 9, 10, 10, 0. And finally you apply the whole one, the 0 and the list. So 0 is an even number, so you add 0 and then 0 plus head of list 1, so it becomes 0, 1, and then the whole list as it is 1, 2, 5, 3, 4, 9, 5, 6, 13, 7, 8, 17, 9, 10, 10, 0. So this is your final answer. And finally you should apply length on this list. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So you have 18 elements in the list. So if you, as it is evaluate this code in Haskell, you will get 18. So 18 is the correct answer. Okay. So any doubts in this question? How I expanded the calls to folder and how the evaluation takes place from right to left. Right.
Clear, sir. Very good explanation. Thank you.
Thanks, Mukesh. Okay. So now for the sake of explanation, for a complete explanation, I expanded all the uh, evaluations, right? But in an exam, you won't have time to derive the whole list sometimes. Okay, so as in like this sort of like a full-fledged tracing of the evaluation, you won't have time also. So for that, what you can do is you can sort of first expand up to this level. Let me use a different. So you can expand up to this level. Okay, so as an f of 10 of 0, you can get all the evaluations, and then if you notice, right, you start evaluating the rightmost one, then the second one, and then the third one. Once you reach the third or the fourth one, right, the evaluations, you will sort of see a pattern in how the result is formed. So if you notice the question what is being asked is, they are not, if they are asking say like what's the third element in the list or what's the last element in the list or something, say like they are asking what's the first element in the list, then you have to fully evaluate, that is complete all the evaluations and find out the whole expression of this folder and then find the first element. But here they are asking the length of the expression only. So instead of doing all the evaluations, so you can just do like 3 to 4 evaluations, and once you find out a pattern in which in pattern how the number of elements are being added to the list, you can easily find out how many elements would be there in the final list. So if you notice, initially after the first evaluation I have 3 elements, so my length is 3 for this list. When I add when I apply f along with 9 and this list, my length is increased by 1, so L is 4 now. And when I apply an even number along with the list, okay, I add 2 elements actually. One is x and then x plus head of y. So my length becomes 6. So now if you notice, there is sort of this pattern. So for, if you apply an even number, you are adding 2 elements. So if it's an even number, you are adding 2 elements to the top of the head of list, and you are retaining the list as it is. Yeah, you are adding 2 elements to the head of list. And if it's an odd number, you are adding just 1 element. One element to the head of list. So if you notice over here, so for f of 7, you are just adding 1 element. So this length of the list is now 7. 1, 2, 3, 4, 5, 6, 7. So now from here, instead of performing the evaluations sincerely, what you can do is you can have the shortcut say, now I'm applying 6, 5, sorry. So now I'm applying f of 6, f of 5, f of 4, f of 3, f of 2, f of 1 and f of 0, and the list length initially over here is, sorry, length of L is equal to length of the list passed here is 7. So initially it is 7. So when I am applying f of 6 and list of length 7, I will be adding 2 elements because the even number is based on what x is. X is an even number or x is an odd number. Right? So my length now becomes 9 because I will be adding 2 elements. So if you notice over here, when I apply f of 6 to this list, I have added 2 elements. And when I apply 5 and the list over here, I have added this element. Right? So now the length becomes 10. So in the same way, now if you see, even number is being applied, my length will become 12. Odd number, it will increase by 1. Even number increase by 2. Odd number increase by 1. Even number increase by 2. So finally, on applying f of 0, you will have a list of 18 elements. So you will finally get a list of 18 elements. You won't know what the contents of the list would be, but the required answer is the length only, and you have arrived at that. So this is sort of like a shortcut. You need not fully evaluate all the evaluations for each element of the list. So this would save significant time in your exam. And also doing these evaluations, there is a high chance that you might make a mistake while evaluating this due to time pressure or your paper, the rough paper sheets that you get, right? That might also be limited, I'm not sure. Right? So this applying shortcuts as and when possible would be helpful for you during the exam. So you should clearly study the question and then approach the answer. So what is required of the solution, what solution is required, you should be clear in that. If they are just asking the length, you should try to this sort of will come in practice only. So instead of doing all the evaluations, your aim should be finding the length of the list. And if you are able to find a pattern on which the length of the list is being increased between 3 consecutive recursive calls, especially in this if-else condition and all those stuff, right? You are having a pattern. So you can easily find out the length of the final list. And if say instead of asking length, right, if they are asking what's the last element of the list, okay, you need not do any of the evaluation. If you just expand the fold-all function, and once you reach this step f of 10 of 0, right, and this is the initial list 10 comma 10 comma 0, this will be the initial list. Okay, basically your accumulator is the list, so you need not evaluate also. So based on the function definition, right, this accumulator is being at the tail of the list always. So the accumulator 0 would be the last element of the list. So you not do any evaluation at all, you can just confidently tell 0 is the last element of the list. So the so this is how you should whenever they ask a fold-all function or anything, have a look at the question, and you should try to see whether you have to do all the evaluations. The safe way is always to do the evaluations, but in an exam situation during time crunch and all those factors coming into picture, you should be a bit smarter and try to optimize your way of working out the solution. And maybe like during your first, say, when in your exam, when you go through the questions first, right, when you come up with an initial answer, you might do this optimized way, and later after attending all the questions, to cross check your answer, to double check, at that time you can do this full evaluation and see what your what the answer is, and compare it with the answer that you had initially got. So you can do these strategies also. So these might be helpful during your exam. So any doubts in this question, in the way I approached, and also the shortcut way that I mentioned, where I'm just calculating the length alone based on the pattern in which the length of the list is being updated. Okay. So in that case, we have discussed almost yeah, all the practice questions. Okay. So apart from these practice questions, do you have any specific doubts in the weekly lectures?
I have doubt in week 2 graded assignment question.
Okay, week 2 assignment question. Right. Uh, which question?
I asked in this so that forum also, but I still not clear. Question number 3. I am unable to derive the expression. You have given the word document, but sorry, unable to figure out this. Question number 3. There we have this G slash X.
1 second.
Or if you have done any live session, then I will go for recording.
Yeah, yeah, I've discussed, I guess.
Yeah, yeah, this question. Yeah, this question, sir.
This question is it?
Yeah, this question only.
Okay.
So can you give the link of recorded session
Yeah,
there?
so actually I have not uploaded the recordings yet. Tonight I'll upload both today's and yesterday's recording. So I've explained this question in detail. So I will upload the recordings, and I will share the exact time at which I'm discussing this question in the Google forum.
Okay, that will be helps.
Okay. So apart from this, any other general queries you have? Okay. So Tyagarajan has asked what would be the difference between f g x and f dot g of x. So both are same actually. Um, okay, maybe in terms of coloring, no, it doesn't make any difference. This dot is sort of like a syntactic sugar. It don't make a difference. It doesn't make any difference. It's just a way of, instead of so say like in real world programs. Say for example, if you are writing a packet filter or something, you are getting a packet, a network packet, and you have to do a series of um, operations on that packet, right? So you have to find out who is the sender, who is the receiver, and the IP address and all those stuff. You will be applying a series of functions, like a pipeline of functions on that packet. So same way how this folder works, right? So if as in not folder, but the result of the first function, that result would be passed to the second function as an argument, something like that, right? So in that case, there will be like sort of too many parentheses if you have to clearly indicate the flow of evaluation. So instead of that, using this dot is sort of a more concise and clear way of writing down programs. Nothing more than that. Okay. Right. Okay. So slash x, what slash x means is it is an anonymous function. So usually when you say like um, foo of x and y equal to x plus y, right? This your function name is foo. This is your function name, and the two arguments are x and y. These are the arguments, right? Now, in higher order functions, for example, this map function or filter function, say filter of, okay, you are passing foo, and uh, so assume this is some logic is there in between, okay. So you are passing foo, and then assume just one argument, so that it goes through. So you are passing foo of, okay, foo of x and um, one slash x. No. Okay, assume, sorry, sum to x. So assume this is the function, and you are applying this function on every element of the list. Sum to, and this is the list 1, 2, 3, 4. So basically what it does is it takes every element of the list and it adds 2 to it, so that you get 3, 4, 5, 6, right? So now um, this is sum2. So this is the function name sum2 which is being passed, and this is sort of a map is a higher order function, that is it takes a function as an argument, okay. So in real world practical programs, um, there are many instances where you will be using these higher order functions like map, filter, folder, and all those stuff. And these would be like frequently used because similar to how you would be using while loop or for loop in your normal C programs, using these map, fold, filter functions is the go-to construct in functional programming languages like Haskell and OCaml. So everything like whatever you sort of want to compute on your list or perform any operation on your list, you will be using almost these functions, and any new data structure or anything you want to create, then also will be trying to your way of thinking, right? The style of programming would be revolving around these functions only, everything using recursive calls and usage of higher order functions, all this stuff only. And one small headache would be uh, when we are using these higher order functions, when like say in a file, in a source code file, if you are using like say hundreds of invocations of this higher order function like map or filter, and for each of these invocation you are passing some function like sum2 or something like this, you are passing a function, and in some places you would be able to give a proper name like sum underscore 2, but in some places you won't be able to come up with a name or something like that. right? So for ease of developer use, what they do is the compiler doesn't expect a name for these functions. So these are known as anonymous functions, which is like nameless. So to denote these anonymous functions, you have this notation called slash x plus 2. So basically instead of the name, you are giving this slash over here, which denotes it's an anonymous function. And why they chose this slash over here is, if you remember, Haskell is sort of the core logic of Haskell. How it was developed is based on a programming language called lambda calculus, the core of Haskell, right? And this lambda is sort of like all are lambda terms. So this is the symbol of lambda. So if you just look at this slash over here, this is what they have identified over here. And these anonymous functions, the other name for these are actually lambdas. And that's from this only we are getting this symbol slash, and it's used to denote anonymous functions or lambdas. So now instead of passing sum underscore 2, you will be having the same function map, the same invocation, but here it will be sort of like x plus 2, and then 1 2 3 4 5. So it's basically instead of giving sum underscore 2, defining it separately and all those stuff, you're using this, you're passing an anonymous function. And your Haskell compiler will give a name within it for its own reference, but as a developer, you need not worry about giving it a name. That the compiler will take care of it. Yeah. Okay. So hope you understood the concept of anonymous functions. Right. Yeah. Thanks, Sashi. So, any other doubts apart from these?
Yeah, just one thought. In some cases, we are putting dot when we are putting this anonymous function. What is the meaning of dot?
Okay. So, dot is nothing but say uh, if you have this sort of a long list of F1 of, F2 of, F3 of, F4 of, F5 of, F6 of, X, right? Now you have to count the number of closing parentheses, right? So 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. And in some cases, this sort of like will be a long list of functions, right? So now instead of having this opening and closing, you can have F1, F2, F3, F4 dot, F5 dot, F6 dot, X.
Okay, okay,
So
okay,
basically
understood.
it
Thank you.
tells F6 result to here, F5 to here, like that. So it's just like a sequencing.
Okay, okay.
So
Thank you.
the arguments passed is same, but just another way. So it's just syntactic sugar. Okay. So any doubts apart from these? So if there are no doubts, then it's 7:50. We can wrap up this session.
So just please upload that week
Yeah,
two.
yeah, sure. By tonight I'll upload it, and I'll
Okay,
share
thank
that
you.
link also for the exact timeline link.
Thank you, sir.
Yeah, okay. So thank you everyone for making this session interactive and asking good questions. See you in the next live session. You will get the announcement.
Thank you, sir.
Yeah, thanks. Thanks, Tyagarajan. Thanks, Sashi. Thanks, Mukesh. Thanks, Sagar.
Thank you, sir.
Yeah.